Hi everybody. So in the last video we discussed angle on a straight line, on a single line. In this video we are going to talk about angles formed by using two straight lines. So we are going to discuss the concept of parallel lines, transversals, corresponding angles and alternate angles, opposite angles, and then we'll put it all together. So let's start with the parallel lines. I hope that concept is pretty obvious. These are two lines that stay equidistant throughout. So no matter how long you extend these lines to right and left, the distance between the two of them will never change. They will never cross each other. They'll stay parallel. They continue to point in the same direction as a result. So now, the next main concept based on that is the concept of transversal. So again, if we have two parallel lines and we draw a line through them, then this cross-cutting line is called the transversal. And as a result of this transversal, many new pairs of angles emerge which have special properties. So the first pair of angles is called the corresponding angles. If you have watched earlier video on congruence, then the first fact that you ought to remember is that these two angles are congruent, which means you just drag the lower angle on top of the upper angle that you can see on your screen, and they will literally cover each other. Yeah, so that's the definition of congruence. So corresponding angles are the angles that are in the same position at each intersection. So you can see that, the transversal is intersecting the two parallel lines, and the two highlighted angles on your screen, they are sort of in the same position at each intersection. So that the higher angle, the upper angle is at the top intersection of the two lines, and the lower angle is at the bottom intersection of the two lines. It's like they're facing in the same direction, you may also say that. And they make an F shape. See, so you can see that F shape marked by the darker line, and the other F shape, which is inverted F shape, drawn with the bluish line. So you can also flip it around, so now you can see the other F. So basically the point of this flipping is that you could have rotated the whole shape and found the corresponding angles there as well, but instead of you physically rotating yourself, I sort of spun the figure, and you can see that the corresponding angles still exist on this side as well. And these are not the only two pairs of corresponding angles. So the corresponding angles can also exist on the other side, below the intersection as well. So here are two corresponding angles. They still make an F shape, and again, obviously, they can exist on the other side as well. So there's another pair of corresponding angles. So I hope you can figure out, there are many pairs of corresponding angles, and they're always equal. They're always congruent. Yeah. In contrast, there are also alternate angles that appear on the opposite sides of the transversal. So here are two alternate angles, and it appears that they make sort of a Z shape. Okay, and they can also exist on the other side, the opposite sides as well. So there's a pair on the opposite side as well. So, and finally, if we cross the two lines together, so instead of having parallel lines, we just let them cross each other. So then we get another couple of pairs, and these pairs of angles are called the opposite angles. So for instance, these two are opposite to each other, and they are congruent as well. Likewise, these two are opposite to each other as well, and they are congruent to each other as well. Remember, not all four of them are equal. Just the pairs are congruent among themselves. So to put it all together, here's a little bit of a mental exercise where we can detect various angles. So we'll figure out which angles are congruent. So angle A is congruent to angle D. I'll let you figure that out. Why? Which of the principles that I discussed in this video applies? So I hope you'll figure out that angle A and angle D are opposite angles. So this is why they are congruent. Likewise, if you look at angle B and angle C, so they're also opposite angles, so they are also congruent. Now we come down to the lower intersection, and angle E is congruent to angle H because that's a pair of opposite angles, and angle G is also equal to angle F because that's another pair of opposite angles. Now let's go across the two intersections, see whether there's any commonality there as well. So angle A is equal to angle E. Now what's the reason? Angle A is equal to angle E. Think about it. Well, they are corresponding angles. Similarly, angle D is equal to angle H. So D and H, I hope you agree, are also corresponding angles. But how do they become, the two pairs become equal to each other? Let's go into the middle equality, which says E equals D. So how is angle E equals to angle D? Well, I hope you can see a Z shape emerging. So angle E and angle D are on the opposite sides of the transverse, and they make alternate angles. And as we have seen, alternate angles are also congruent. So hence, all the four angles are equal. And similarly, angle B equals F equals C equals G. The same reasoning applies. So let's figure out the angle B and F. So angle B is at the top intersection, and angle F is at the bottom intersection. B equals F because they are corresponding angles, and C equals G. So angle C is at the top intersection and G is at the bottom intersection. They are also corresponding, so they are also equal. And then we look at the middle equality, which is F equals C. So angle F is on the right side of the transversal, angle C is on the left side of the transversal, and they are both alternate angles, hence they are also equal. And that makes all the four angles equal as well. So both sets of angles are congruent. So with that, we finish off this video, and I hope to see you in the next one. Thank you.